Formula One is not just a race, it is the fastest, most advanced moving laboratory on Earth. When you see F1 cars flying past at 350 to 370 kilometers per hour, you are not watching normal vehicles. You are watching machines that operate at the absolute limits of physics, engineering, and human endurance. These cars generate so much downforce that, in theory, they could drive upside down inside a tunnel. Every corner, every braking zone, and every millisecond matters. In a single race, a driver can lose 2 to 4 kilograms of body weight, experience G-forces stronger than a fighter pilot, and maintain peak focus for nearly 2 hours without a single mistake. What makes modern Formula One even more fascinating is how rapidly it is evolving. In recent seasons, F1 has entered a new era focused on sustainability and efficiency. Today's 1.6-litre V6 turbo hybrid power units are among the most efficient engines ever built, converting nearly 50% of fuel energy into usable power, something even road cars and aircraft engines struggle to achieve. These engines don't just burn fuel, they recover energy from heat and braking using advanced ERS systems, store it in batteries, and redeploy it for acceleration. This technology is directly influencing the future of electric and hybrid road cars. Aerodynamics has also reached an entirely new level. Recent regulation changes were introduced to allow cars to follow each other more closely, increasing wheel-to-wheel racing. Ground effect tunnels under the car now generate most of the downforce, reducing turbulent air and making overtaking easier. This single rule change transformed racing quality and proved how deeply science shapes the sport. Engineers now use supercomputers, wind tunnels, and AI-driven simulations to optimize airflow down to fractions of a millimeter. Data has become the hidden hero of Formula One. Each car carries more than 300 sensors, generating over 1.5 terabytes of data per race. This data is analyzed in real time by engineers both at the track and back at the factory, sometimes thousands of kilometers away. Tire degradation, brake temperatures, fuel flow, weather shifts, and driver inputs are constantly monitored. Race strategies are adjusted lap by lap using predictive models and simulations. In many ways, modern F1 is as much about algorithms as it is about driving skill. Driver performance has also evolved. Today's F1 drivers are elite athletes with reaction times around 100 milliseconds, faster than the blink of an eye. Their neck muscles are trained to withstand forces equivalent to holding 40 kilograms during high-speed corners. Heart rates stay near 170 to 180 beats per minute for the duration of a race, similar to running a marathon at sprint intensity. Add extreme cockpit heat, mental pressure, and split-second decision-making, and you begin to understand why only a handful of people on the planet are capable of competing at this level. Pit stops remain one of the most dramatic elements of Formula One. Entire teams of over 20 highly trained crew members change all 4 tires in under 2 seconds. This is not just speed, it is precision under pressure. A single mistake can cost a race. Teams now use motion analysis, AI-assisted training, and thousands of practice runs to shave off hundredths of a second. These pit crews are among the fastest coordinated human teams in the world. Formula One is also becoming smarter and safer. Biometric gloves now monitor drivers' heart rate and oxygen levels in real time. Advanced crash structures, the Halo safety device, and continuous medical monitoring have made F1 dramatically safer than in past decades, without reducing speed or excitement. At the same time, sustainability goals are reshaping the sport, with plans for fully sustainable fuels and net-zero carbon racing operations in the coming years. Perhaps the most important thing to understand is this: Formula One is not just entertainment. It is where future technology is tested first. Carbon fiber construction, hybrid systems, energy recovery, advanced aerodynamics, real-time data analytics, and AI-driven strategy, and many of these innovations eventually make their way into everyday cars. What you see on the track today often becomes standard technology on the road tomorrow. That is why Formula One is called the pinnacle of motorsport. It is not only a race between drivers or even teams, it is a race between ideas, engineering brilliance, and the relentless pursuit of perfection at 350 kilometers per hour. Another major transformation in modern Formula One is how technology and regulations are shaping the future of mobility. F1 is no longer only about being the fastest, it is about being the smartest and most efficient. The sport is actively preparing for the next generation of engines planned for 2026, which will mark one of the biggest rule changes in F1 history. These new power units will rely even more on electric energy, with nearly 50% of the total power coming from electrical systems. This shift is designed not just for racing, but to align Formula One with the future of global automotive technology. Fuel technology is also undergoing a silent revolution. F1 cars are moving toward 100% sustainable fuels made from synthetic and bio-based sources. These fuels are designed to be carbon neutral, meaning the co-released during combustion is offset by the co-absorbed during fuel production. What makes this exciting is that these fuels are not just for racing, they are being developed in a way that they can be used in normal internal combustion engines without modification. In simple words, F1 is helping save combustion engines instead of killing them. Another cutting-edge area is AI and machine learning. Teams now use artificial intelligence to simulate millions of race scenarios before a single lap is driven. AI predicts tire wear, weather changes, safety car probability, and optimal pit windows. During the race, machine learning models continuously update strategies in real time. Even driver coaching has changed. AI analyzes braking points, steering inputs, and throttle control to help drivers improve lap after lap. Virtual testing has become more important than physical testing. Due to cost caps and limited track testing, teams rely heavily on simulators that are so advanced that drivers can feel tiny changes in suspension, grip, and aerodynamics. These simulators are directly connected to real-world data from previous races. Cost control has also reshaped the sport. Earlier, top teams could spend unlimited money, creating huge gaps between rich and small teams. Now, a budget cap limits how much each team can spend per season. This has made competition closer, increased unpredictability, and forced teams to become more innovative instead of just spending more. Engineers must now choose where to invest every single dollar carefully, whether in aerodynamics, reliability, or performance upgrades. Fan engagement has changed dramatically as well. With live telemetry, onboard cameras, driver radio messages, and advanced graphics, viewers can now understand racing strategies better than ever. Social media, streaming platforms, and behind-the-scenes content have brought fans closer to teams and drivers, turning F1 into a global digital sport rather than just a TV event. Even safety innovations continue to evolve. Advanced crash simulations, energy-absorbing structures, fire-resistant materials, and medical response systems are constantly upgraded. Data from crashes is analyzed to improve future car designs, ensuring that extreme speed does not come at the cost of human life. Behind all this, Formula One remains a perfect blend of man and machine. No matter how advanced the car becomes, it is still the driver who must control it at the edge of physics. One small mistake, one late break, or one wrong decision can change everything. That is why Formula One remains unpredictable, intense, and endlessly fascinating. More fascinating layer of Formula One is how tiny rule changes create massive performance differences. In F1, a design change as small as a few millimeters on a wing, floor edge, or diffuser can decide whether a car wins races or struggles at the back. That's why teams invest thousands of engineering hours just to gain 1/10 of a second. In F1 terms, 1/10 is huge. It can be the difference between pole position and starting mid-grid. Another critical evolution is tire science. F1 tires are not designed to last long. They are designed to perform at maximum grip for a short window. Modern F1 tires operate in a very narrow temperature range. If they are even slightly too cold or too hot, grip drops instantly. This makes tire management a core driver skill. Drivers must control braking, steering, and throttle smoothly to keep tires in the perfect temperature zone. That's why some drivers are called tire whisperers. They can extract performance while protecting tire life. Weather adds another unpredictable dimension. A sudden drop in track temperature, light rain, or wind direction can completely change grip levels. teams constantly monitor weather radar, track evolution, and surface temperature. Sometimes, a single well-timed pit stop during changing conditions can turn an average race into a historic win. This is where human decision-making and data-driven strategy collide. Formula One is also deeply connected to aerodynamic trade-offs. Cars set up for high downforce perform exceptionally well in corners but lose speed on straights. Low downforce setups are faster on straights but harder to control in turns. Teams must choose compromises based on the circuit. Tracks like Monaco demand maximum downforce and precision, while tracks like Monza prioritize straight-line speed. There is no single perfect car, only a car optimized for specific conditions. Another modern development is driver feedback shaping car design. Unlike road cars, F1 cars are highly customized to each driver's driving style. Steering sensitivity, brake feel, seat position, pedal stiffness, everything is tailored. Engineers constantly adjust setups based on driver input, data analysis, and simulator feedback. The relationship between driver and engineer is crucial. Trust and communication can directly translate into lap time. Formula One logistics are another marvel. The championship travels across continents, moving hundreds of tons of equipment between races within days. Entire garages, cars, spare parts, and data systems are dismantled, shipped, and rebuilt with military-level precision. The sport is also becoming more globally inclusive and future-focused. New markets, new circuits, and younger audiences are reshaping how Formula One is presented. At the same time, F1 is investing in diversity programs, junior driver development, and grassroots motorsport to ensure a steady pipeline of talent for the future. At its core, Formula One remains a sport where physics is pushed to the limit under human control. Every lap is a balancing act between grip and slip, speed and stability, aggression and precision. Cars operate at the edge of traction, engines at the edge of efficiency, and drivers at the edge of concentration. This is why Formula One is never just about who is fastest, it is about who can operate closest to perfection for the longest time. Another deeply fascinating side of Formula One is how human psychology and pressure management play a role equal to engineering. At 350 kilometers per hour, there is no time to think in full sentences. Decisions are made instinctively, trained through thousands of hours of repetition. Drivers must block out noise, crowd pressure, radio chatter, and even fear. One tiny lapse in concentration can end a race or a career. That's why mental conditioning, visualization techniques, and reaction training are now as important as physical fitness. Modern F1 drivers train their brains using neuro-training systems. These include light reaction boards, multi-object tracking exercises, and split-second decision simulations. Some drivers train using strobe glasses that block vision intermittently, forcing the brain to predict movement. Another key evolution is energy management during a race. F1 is no longer flat-out racing from start to finish. Drivers must carefully manage battery deployment, fuel usage, brake temperatures, and tire life, all at the same time. The steering wheel becomes a command center where drivers constantly adjust settings lap by lap. The relationship between driver and race engineer is one of the most unique partnerships in sports. The engineer is the driver's eyes beyond the cockpit, analyzing data, predicting threats, and suggesting strategies. Communication must be calm, clear, and precise, even under extreme stress. Formula One has also become a global testing ground for materials science. Carbon fiber composites, heat-resistant alloys, advanced ceramics, and lightweight metals are pushed beyond normal limits. These materials must survive extreme vibration, heat, and force while remaining as light as possible. Many of these innovations later appear in aerospace, defense, and high-performance road vehicles. Another major advancement is safety evolution through data. Every crash is analyzed in detail: impact angles, deceleration forces, chassis deformation, and driver biometrics. This data feeds into future safety designs. The Halo device, once controversial, has already saved multiple lives. Environmental responsibility is now a core focus. Formula One aims to become net zero carbon by the end of the decade. Freight logistics, factory operations, and race events are being redesigned for sustainability. Hybrid engines, sustainable fuels, and energy-efficient logistics are not just marketing, they are engineering priorities. At the same time, Formula One remains brutally competitive. Only 20 drivers exist in the entire world at this level. Every season, young talents from Formula 2 and junior categories fight for a single opportunity. One bad season can end a career. One exceptional performance can define a legacy. This constant pressure is what makes Formula One so intense. Every lap is a test of courage, intelligence, endurance, and precision. Every race is a reminder that at the highest level, perfection is not a goal, it is a requirement. One of the most underrated but powerful aspects of Formula One is how rules themselves become weapons. In F1, everyone races under the same rulebook, but the smartest teams learn how to interpret those rules creatively, without breaking them. This is where legendary innovations are born. Double diffusers, DAS steering systems, flexible wings, and ground effect floors all came from teams reading the rulebook more deeply than others. In Formula One, innovation doesn't always mean inventing something new, it means finding space inside constraints. Another crucial layer is race strategy psychology. Strategy is not just math, it's anticipation. Teams constantly try to predict what rivals will do next. If one team pits early, another may stay out to gain track position. If rain is expected, teams gamble on staying out longer. Sometimes, winning comes not from having the fastest car, but from making the bravest decision at the right moment. Formula One is also deeply shaped by track evolution. A circuit is never the same from lap 1 to lap 50. As cars run, rubber builds up on the racing line, increasing grip. Another modern advancement is remote operations. During races, large parts of the engineering team are not even at the track. They sit in control rooms at factories in Europe, monitoring live data and running simulations in parallel. Decisions made thousands of kilometers away can affect what happens on the track in real time. Driver development has also evolved. Young drivers today start training as early as 6 or 7 years old in karting. By the time they reach Formula One, they have driven millions of simulated and real kilometers. Their necks, reflexes, and spatial awareness are trained from childhood. Formula One's influence now extends far beyond racing. Its technologies feed into road safety, electric mobility, battery efficiency, and even aerospace research. Many concepts tested at extreme limits in F1 later appear in everyday vehicles, quietly improving safety and efficiency for millions of people. At its heart, Formula One remains a constant struggle between control and chaos. Engineers try to predict everything, but racing always leaves room for the unexpected, mechanical failures, weather shifts, safety cars, or human error. That unpredictability is what keeps the sport alive and thrilling. Every race is a reminder that Formula One is not just about speed, it is about mastering complexity under pressure, again and again, with no margin for error. In the end, Formula One is far more than cars racing in circles. It is the purest form of competition where human courage, machine precision, and cutting-edge technology collide at extreme limits. Formula One also teaches a powerful lesson: winning is never about one factor alone. The fastest car means nothing without the right strategy. The best strategy fails without a calm driver. Even the greatest driver cannot win without engineers, mechanics, data scientists, and pit crews working in perfect harmony. That is why Formula One continues to fascinate millions across the world. It is speed, science, risk, and discipline combined into one spectacle. Every season rewrites history, every race creates new heroes, and every innovation pushes the limits of what humans and machines can achieve together. This is not just racing, it is the future being tested at 350 kilometers per hour. And the most fascinating part is this: Formula One never stops evolving. The rules change, cars change, engines change, even driving styles change. What was considered impossible 5 years ago becomes normal today. Hybrid power units, energy recovery systems, advanced aerodynamics, AI-driven race strategies, and real-time data analysis have turned F1 into a living laboratory of future technology. Many of the innovations tested under these extreme conditions slowly make their way into our everyday lives. Safer car structures, better braking systems, fuel efficiency technologies, hybrid engines, battery management, lightweight materials, almost every modern road car carries DNA that was first perfected on an F1 circuit. In that sense, Formula One is not just about entertainment, it is about shaping the future of mobility. Above all, Formula One represents the human desire to push boundaries, to go faster, think smarter, and perform better under pressure. It shows what happens when ambition meets discipline, when intelligence meets courage, and when technology is pushed to its absolute limit. That is why Formula One is not merely a sport. It is engineering at full throttle, science under stress, and humanity racing against time itself. If this video helped you learn something new or gave you a fresh way of thinking, then it was worth sharing. We put a lot of care and research into bringing you content that's truly useful and meaningful. If you enjoy learning and growing through videos like this, subscribe and stay with us. Thank you for watching. See you in the next one.